Here's a startling fact to kick things off. Did you know that approximately 21 million Americans have at least one addiction, yet only 10% of them receive treatment? That's right. This means that millions of people are grappling with the chains of addiction, battling this life-altering condition on their own, often unnoticed or misunderstood by those around them. It's a staggering reality we face, and it's a crisis that's largely hidden in plain sight. The scope of this problem is immense, and the urgency to address it is undeniable. Addiction isn't just about the individual, it sends ripples through families, communities, and society as a whole. It's a silent epidemic, and its effects are far-reaching. So, what's happening in our brains when we get addicted? Why is it so hard to break free? These are some of the questions we'll explore. With such a widespread problem, it's crucial to understand what's going on in our brains when addiction takes hold. Addiction is more than just a bad habit. It's a complex interplay of brain chemistry, genetics, and environment. Let's delve deeper into the science behind addiction. Picture this. Your brain is like a city with a complex network of roads. These roads are your neural pathways, the routes your brain takes to send messages. In a healthy brain, the messages travel smoothly like traffic on a well-maintained highway. But when addiction enters the picture, it's like a traffic jam, disrupting the flow of messages and causing chaos in the brain's communication system. At the heart of this chaos is the brain's reward system, a group of neural structures responsible for our feelings of pleasure. These structures are activated when we engage in activities we enjoy, like eating a delicious meal or spending time with loved ones. But addictive substances can hijack this reward system, causing it to release a flood of dopamine, a neurotransmitter associated with pleasure. This creates an intense feeling of euphoria, leading the brain to crave more of the substance to recreate this high. Over time, the brain adapts to the excessive dopamine by producing less of it. This means the person needs to consume more of the substance to feel the same level of pleasure, a phenomenon known as tolerance. When the substance is removed, the individual experiences withdrawal symptoms as the brain struggles to function without the elevated dopamine levels it's become accustomed to. Recent research has revealed that addiction is not a moral failing, but a brain disease. The American Society of Addiction Medicine defines addiction as a chronic disease of brain reward, motivation, memory, and related circuitry. This means that people struggling with addiction aren't simply lacking in willpower, but are battling a disease that fundamentally alters their brain's function and structure. Understanding the science of addiction allows us to approach it with compassion and empathy rather than judgment. It's clear that addiction is not a choice but a disease that alters the brain's function and structure. In the heart of addiction lies a powerful neurotransmitter, dopamine. This tiny molecule, a mere speck in the grand scheme of our complex brains, holds a monumental responsibility. It is the ringleader of our brain's reward and pleasure centers, the master puppeteer pulling the strings of our desires and motivations. You see, every time we do something enjoyable, dopamine is released. It's like the brain's way of giving us a pat on the back, a little well done, for engaging in behaviors that, in theory, contribute to our survival. Eating a delicious meal, spending time with loved ones, achieving a goal, all of these actions trigger a release of dopamine, resulting in that warm, fuzzy feeling we all know and love. But what happens when this system designed to reward survival behaviors gets hijacked? This is where the dark side of dopamine reveals itself, and we begin to understand its role in addiction. Substances like nicotine, alcohol, and illicit drugs don't just stimulate dopamine production, they supercharge it, flooding the brain with levels of dopamine up to 10 times higher than natural rewards would. The result? An intense high that leaves the brain craving more. This artificial stimulation creates a shortcut to the brain's reward system, a detour that bypasses the normal hard work and patience required to achieve natural highs. Over time, the brain comes to prefer this shortcut, developing a dependency on these substances to feel good, and it doesn't stop there. As the brain gets used to these dopamine surges, it starts to reduce its natural dopamine production in response. This means that without the substance, dopamine levels plummet, leading to withdrawal symptoms and making it even harder to break free from the cycle of addiction. So while dopamine is not the villain, it's an accomplice, an unwitting pawn in the game of addiction. Understanding its role is crucial in our battle against addiction and in developing treatments to help those caught in its grip. The more we understand about dopamine, the more we realize its pivotal role in addiction. The toll of addiction on an individual's life and health is devastating. It's like a storm that sweeps through a person's life, leaving a path of destruction in its wake. Physically, addiction can ravage the body. It can lead to a myriad of health complications, from heart disease to liver failure and even death. But the impact of addiction isn't just physical, it's emotional as well. It can lead to feelings of shame, guilt, and isolation. It can break down relationships and shatter families. Socially, addiction can be a barrier to education, employment, and community involvement. It doesn't discriminate. It can affect anyone, whether you're a teenager from the suburbs or a CEO in the city. And let's not forget, addiction isn't just an individual problem, it's a social issue. It affects our communities, our economy, and our society as a whole. Addiction is not just a personal problem, but a social issue that affects us all. While addiction is a formidable foe, there is hope for recovery. In the face of addiction, it's easy to feel overwhelmed. But remember, we're not powerless. Current treatment options, combined with the promise of neuroscientific research, are paving the way to more effective therapies. Let's take a moment to consider these options. Traditional treatments like counseling and cognitive behavioral therapy have proven beneficial for many. They help individuals understand their addiction, learn coping strategies, and realize that they're not alone in their struggle. Then there are medications, another cornerstone of treatment. They can help manage withdrawal symptoms and cravings, making the process of recovery more manageable. But the real game changer is the advances in neuroscience. Our understanding of the brain, its functions, and how it interacts with substances of abuse has grown exponentially in recent years. This knowledge is helping us develop new and improved treatments. For instance, we now have therapies targeting the brain's reward system, the very epicenter of addiction. Imagine therapies so precise they can target the very neurons involved in addiction, potentially offering a more effective and personalized treatment route. It's like finding the exact key for a lock instead of trying every key on the ring. But let's not forget the most crucial part of this puzzle: seeking help. Addiction is not a sign of weakness or lack of willpower. It's a disease, and like any other disease, it requires treatment. Breaking the stigma around addiction is paramount. It's not something to be ashamed of, and seeking help is not an admission of defeat, but rather a courageous step towards recovery. As we delve deeper into the intricate workings of the brain, we inch closer to turning the tide on addiction. The future of addiction treatment is bright, filled with hope and promise. With understanding, compassion, and science, we can turn the tide on addiction. Let's continue this journey together, exploring the mysteries of the brain and finding hope in the face of addiction.